everyone, myself Sai Prasad, Alexa in Hyderabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We have started our discussion with the chapter Circles. What did we learn? We started with the basics of circles, then the equation of tangents, okay, and we also learned how do we find the equation of a circle in different conditions. We also learned that when a center and a circle is given, we can find the length of a chord also. Yes, shall we do a few more problems of all those types? Let us do. The first question given here it is, find the equation of a circle with center 2, 3 and touching a line, this line is given. How do we solve? For example, if this is a circle with center 2, 3 and it is touching this circle, touching this line. Yes. Then what is the condition we discussed? If a circle is touching a line, then it is a tangent. Then what is the condition for a tangent? That is, the condition for a line to be a tangent of a given circle is the perpendicular distance from the center to this line should be nothing but radius. Okay. Remember the condition that a line to behave as a tangent to a circle is r is equal to d. What is d? That is the perpendicular distance from the center to the line. Clear? Shall we do? Now see here he is telling that to find this equation, center is given, we have to find the radius. What is the radius? Radius is nothing but the perpendicular distance from the center to this equation. Clear? So let us write center minus g minus f is 2, 3. Okay. Then given 3x minus 4y plus 1 is equal to 0 is a tangent to circle. Okay. So condition is the radius of a circle is equal to perpendicular distance from 2, 3 to 3x minus 4y plus 1 equal to 0. Clear? So we can directly find radius is equal to mod ax1 plus by1 plus c by under root a square plus b square. Okay. That is, we have to substitute this point in this equation. So it will be 3 into 2 minus 4 into 3 plus 1 by under root x coefficient square plus y coefficient square. Clear? So it will be 3 2s are 6 minus 12 plus 1 divided by 9 plus 16. Okay. 6 minus 12 is obviously minus 6, 1 minus 6 is 5 divided by it is minus 5 and here it is 9 plus 6 is 5. Okay. Therefore, the radius is 1. Radius is 1 and the center is 2, 3. Then what is the equation of a circle? Equation of circle is x minus 2 whole square plus y minus 3 whole square equal to 1 square. Isn't it easy? What is the condition we have to remember? R is equal to d. Okay, fine. Look at the next question. Find the equations of tangents of a circle at a point whose ordinates are 1. Clear? So we can write it as let points be x1, 1. Okay. We do not know what is x coordinate, right? He gave that the ordinates is 1. Whatever the value of x, the ordinate is 1. Clear? And next he is telling that the equations of tangents to the circle. So let us find the tangent at this point. What do we get? The tangent is S1 equal to 0. Yes. How do we write? X x1 plus y y1 minus 4 into x plus x1 minus 1 into y plus y1 plus 12 is equal to 0. Isn't it? So what is x1 here? What is y1? x1 is nothing but x1, y1 is 1. Let us substitute it. then we get it as x1 square, x1 into x1, and here y into y1. Okay, what is y? Tell me. Y is nothing but y1. So, this will be y1 into y1, right? What is this? 1 into 1, 1 minus 4 x1 plus x1, that is nothing but 8 x1, and here 1 plus 1, that is 2 plus 12. So, we will get it as x1 square minus 8 x1, and here 12 minus 2 is 10, 10 plus 1 is 11. Clear? Did you understand till here? Here the point is point is x1 comma y1. Okay, just we have to substitute this x1 y1 here again, because the line passes through this. So, we can directly get it as x1 square minus 8 x1 plus 11 equal to 0. Is it right? So, let us factorize this. What do we get? x1 is equal to 8 plus or minus under root of 64 minus 44 by 2. Okay. So, it will be 8 plus or minus 64 minus 44 is root 20. This is x1. So, 8 plus or minus root 20 can be written as 4 root 5, that is nothing but 2 root 5. So, I will get x1 as 8 plus, let us take 2 common, I will get it as 4 plus or minus root 5. Is it right? So, my points will be 4 plus root 5 comma 1 and 4 minus root 5 comma 1. Clear? So, just substitute these values in this equation, or else in this equation we will directly get the equations of tangents. Is it clear? See here, let us substitute any one of the point. So, what do we get? x1 plus y1 minus 4 into x plus x1. So, it will be x1, let us take it as 4 plus root 5 plus y into 1 minus 4 into x plus x1, that is x plus 4 plus root 5, okay, minus 1 into y plus 1 plus 12 is equal to 0. Let us simplify this. This will be, let me take everything common here, or else let us multiply everything all together. 4x plus 4 root 5 minus y minus 4x, and here minus 16 minus 4 root 5, and here minus y minus 1 plus 12 is equal to 0. Okay. So, what do we get here? This will be x into root 5, right. So, I will get it as 4x will get cancelled, and if you observe this y and y also will get cancelled. Clear? So, I will be left with root 5x, and the next 12 minus 12 minus 1 is 11, 11 minus 16 is minus 5 minus 4 root 5. So, root 5x minus 5 minus 4 root 5 is my answer. This is the equation of tangent for first point. Similarly, we can find the equation of tangent for second point also. Is it clear? Shall we move on to the next question? Let us do. Look at the question here. He is telling that prove that the tangent at this point of a circle touches the circle, then find its point of contact. So, how do we write? First circle has a tangent at some point 3 comma minus 2. Okay. He is telling that this tangent touches the second circle itself. So, let us draw somewhere here. Okay. So, we have to find this point of contact. Clear? What is the condition we have to do? Firstly, we have to find this circle. Okay. That is, we have to find this tangent. How do we find? That is using this 3 comma minus 2, we can find the tangent. So, let us write, given first circle, let us write like this from this time. Let us say S, that is x square plus y square minus 13 is equal to 0. Is it? So, the tangent S1 equal to 0. that is xx1 plus yy1 minus 13 is equal to 0. So, what do we get? X into 3 y into minus 2 minus 13 is equal to 0, that is 3x minus 2y minus 13 is equal to 0. This is the equation of tangent. We got the equation of tangent, right? So, he is telling prove that this tangent is touching this circle. How do we prove? Simple thing, r is equal to d. We have to find the radius of this and find the perpendicular distance from C to this line. Can we do? Yes, we can. See, how do we do is, first let us take second circle, that is x square plus y square plus 2x minus 10y minus 26 equal to 0. Clear? So, what is the center for this? Center is equal to minus 2 comma 10. Yes or no? That is minus 1 comma 5. Clear? What is the radius? Radius is under root 1 plus 25 minus 26, that is nothing but 1. We got radius and we got center. So, let us find d. D is perpendicular distance from this point to this line, that is minus 3 minus 10 minus 13 by under root 9 plus 4. Is it? That is, we have to substitute this point, that is minus 3 minus 10, okay, and minus 13. Minus 3 minus 10 is minus 26, which is 26 by, and here it is 9 plus 4, that is nothing but 13. So, what do we get? 26 can be written as root 13 into, here also this is 2, right. So, this is also 2 root 13, do not get confused. So, once again check here, C is given, R is 1 plus 25 plus 26, which is 52, that is 2 root 13. Perpendicular distance is just substitute the point here divided by 9 plus 4, that is 13, and here it is mod minus 26 is 26. 26 can be written as 13 into 2, 13 can be written as root 13 root 13. These both will get cancelled, I will get it as 2 root 13. So, I can write R is equal to D, therefore, equation 1 is a tangent to S dash equal to 0. Clear? Fine. Similarly, the next thing we are going to do is, since this is touching this circle, we have to find this point of contact. How do we find? We have numerous ways. One easiest way is, again using some point, find a tangent, divide it with this, you will get x1 and y1, okay. And one more thing is, we can find this foot of the perpendicular, if you remember, okay. So, let us do nominal form, that is, let us assume a point, find the equation of tangent, divide. Let P is x1 y1 be point of contact. So, I will get it as tangent for this, that is xx1 plus yy1 plus 1 into x plus x1 minus 5 into y plus y1 minus 26 equal to 0. Is it clear? So, let me take everything as x as common, I will get it as x1 plus 1, y1 as common, y as common, I will get it as y1 minus 5 here. Then I will be left with plus x1 minus 5y1 minus 26 equal to 0. Let us take it as equation 2. If you observe, these both lines represents the same line, equation 1 and 2 represent same line, okay. So, we can write it as x1 plus 1 by 3, y1 minus 5 by minus 2, x1 minus 5y1 minus 26 by minus 13. So, let us equate any two of the equation and find the solution. Clear? Let us equate these both first. So, what do we get? Minus 2x1 minus 2 is equal to 3y1 minus 15. Clear? Minus 2x1 minus 2 is equal to 3y1 minus 15. Okay, let us bring all to one side, that will be 2x1 plus 3y1. If this 2 come this side, that is minus 13 equal to 0. Clear? And the next, let us equate these both. Fine. That is 13 minus 13y1 minus 2 minus plus 65, that is equal to minus 2x1 minus 2 minus plus 10y1 minus 2 minus plus 52. Clear? So, this will be 2x1 and the next 10 minus 13, that is minus 13 minus 10, that will be minus 23y1, 65 minus 52, how much is it? 13. Check again, 2x1, 10 minus 23, and here it is plus 13. Here these both equations we have to solve. Clear? Let us take it as equation 3 and equation 4. Okay. Since I can find this 2x same here, can I cancel? So, let us do 3 minus 4. What do we get? 2x1 plus 3y1 minus 13 is equal to 2x1 minus 23y1 plus 13 is equal to 0. I will get it as minus plus minus. These both will get cancelled. 23 plus 3 is 26. Minus 13 is minus 26. So, I will get it as y1 as 1. Is it? And let us substitute this in any one of the equation. Let us say in 1. From 3, I will get it as 2x1 plus 3 minus 13 equal to 0. That is 2x1 minus 10 equal to 0. I will get it as x1 as 5. Therefore, point of contact is 5, 1. Clear? Fine. This is some kind of lengthy, but you have to solve in a easiest way. If you can't do in this method, directly you can find that foot of the perpendicular method, foot of the perpendicular formula. Okay. Shall we move on to the next problem? Let's do. Look at the next question here. He is directly asking you to show that a line is given, touches the circle and find the point of contact. Okay. This is a circle and this is a line. Okay. He is directly telling we have to prove that R is equal to D. So, let us take this equation given S, that is x square plus y square minus 3x plus 7y plus 14 equal to 0. What is the center for this? 3 by 2 minus 7 by 2, isn't it? So, what is radius? Radius is under root 9 by 4 plus 49 by 4 minus 14. So, it is 9 plus 49, 14 4s are 56 by 4, right. 49 plus 9 is 58, 58 minus 56 is 2 by 4, that is nothing but 1 by root 2. This is my radius. Check whether the perpendicular distance is same or not. So, we find perpendicular distance is equal to mod x plus y plus 1, that is 3 by 2 minus 7 by 2 plus 1 by under root 1 plus 1, right, a square plus b square. So, take the LCM here, I get it as 3 minus 7 plus 2, right, divided by root 2. How much is it? 2 by 2 root 2, 2 will get cancelled, I will get it as 1 by root 2. If you observe, R is equal to D, okay, R is equal to D. Therefore, equation 1 touches S equal to 0, clear. And the next, finding the point of contact. This can be done in many ways, once again I am telling. So, let us find the tangent by assuming a point, then equate it with this equation, we will directly get the answer. Let P x1 comma y1 be point of contact. So, what do we get? X1 plus y1 minus 3 by 2 into x plus x1 plus 7 by 2 into y plus y1 plus 14 equal to 0. Clear? Let us take LCM and multiply directly. 2x(x1), 2y(y1) minus 3x(1) plus 7y plus 7y1 plus 28 equal to 0. So, if I take x common, so I will get it as 2x1 and minus 3. If I take y common, 2y1 plus 7y. So, minus 3x1 plus 7y1 plus 28 equal to 0. Is it right? This equation and this equation represent same. Equation 1 and 2 represent same line. So, I can write it as 2x1 minus 3 by 1, 2y1 plus 7 by 1 minus 3x1 plus 7y1 plus 28 by 1. Just equating. Let us equate these both. I will get it as 2x1 minus 3 is equal to 2y1 plus 7. Bring all to one side, 2x1 minus 2y1 minus 10 equal to 0. Clear? And the next here. Let us equate these both. 2y1 plus 7. Let us bring all before itself. 3x1 minus 7y1 minus 28 equal to 0. I will get it as 3x1 minus 5y1 minus 7 minus 21 is minus 21 equal to 0. Clear? So, what shall we do is, let us take 2 common from this. I will get it as x1 minus y1 minus 5 is equal to 0. Now, let us multiply 3 to this. Okay, I am writing everything directly. Let us multiply 3 to this and write here 3x1 minus 3y1 minus 15 is equal to 0. Subtract. 3 minus 5 is minus 2y1 and here 15 minus 21, that is minus 6. I will directly get y1 is equal to minus 3. Clear? Substitute this y1 in any one of the equation. I will get it as x1 plus 3 minus 5 is equal to 0, that is x1 minus 2 is 0, x1 is equal to 2. Therefore, point is 2 comma minus 3. Is it right? You understand? What did we do? We started from the basic, proving that this equation touches the circle. So, we will prove R is equal to D ka condition. After that, again we have to assume x1 and y1, then find the equation of the tangent, and we have to tell that this equation and this equation represents same line. So, after finding the x1 and y1, after equating, we will get the values of x1 and y1, that is nothing but our point of contact. Clear? Did you understand? Fine. This is for today. Let us meet in the next session with the more problems of circles. Thank you.